So today is September 25th. It is Tuesday, and this is what we did in class. We filled out the graphic organizer of how to read a chemical formula. So this is a chemical formula. This first number in the front is a large number that's called a coefficient, and what it does is it tells the number of molecules that we have. And then over here we have the element symbols. So Ca and F are symbols, and they show the elements in the compound. And then 2 and 3 are subscripts, and they tell how many atoms of each element that there are. So this is a set ratio between the two elements in the compound. So my set ratio here is a 3:2 because I have 3 calciums bonded to 2 fluorines. So let's talk about what this means. I have 4 molecules. This is calcium fluoride because I've got the symbols here. So 1 molecule of calcium fluoride is going to contain 3 atoms of calcium and 2 atoms of fluorine. So if I were to draw this out, I would have 3 atoms of calcium bonded to 2 atoms of fluorine. It really doesn't matter how you want to draw these. It just make sure that they're touching each other in a group, because that's going to make a molecule. When you get to chemistry, they'll talk about shapes of molecules and things, but right now we just need to know that this is a molecule, it's a group together. So there are actually 4 of these. So this is 1 molecule of calcium fluoride. But if I were to draw this entirely, I would draw 4 sets. This is 1 set. I would draw another set like that, another set, and another set to make calcium fluoride. So each molecule is going to have 3 calciums bonded to 2 fluorine. That's where this number 3:2 comes into play, because the ratio every time I add a molecule, I'm adding 3 calciums bonded to 2 fluorines every single time. So over here in our examples that we did, we're going to just pause on this ionic and covalent for a minute. We went over here and we did these examples together. So we talked about what each one is and how you get to where you're going. So sodium sulfide is this one. So I have 2 sodiums bonded to a sulfur. 2 sodiums, 1 sulfur, and the ratio is 2:1. Pretty straightforward. This one here is magnesium sulfide. So I have 3 molecules of magnesium sulfide. 1 molecule looks like this. But when I do 2 molecules and 3 molecules, like it asked me to do, I have 3 sets. So this is telling me how many sets, how many molecules I have. And in each one, I have 1 magnesium and 1 sulfur. If I don't have a subscript, or if I don't have a coefficient, it's assumed to be 1. So if you like to, you could write those in there to see that. So when I draw 3 magnesium sulfide molecules, I get something that looks like this. And totally in the box, I have 3 magnesiums and 3 sulfurs, and that is a 1:1 ratio, because I have 1 magnesium to 1 sulfur. My ratio here is coming from my subscripts there. Just like 2:1 is 2:1. There's no 1 there, but there is assumed to be a 1. So your ratio comes from your subscripts. So when I look at my next one, iron chloride, my ratio comes from my subscripts. Remember, there's nothing underneath the Fe, so that's assumed 1. That's a 1:2. So I've got a 1:2 ratio. I've got 2 molecules. Totally in the box, I have 2 iron atoms, 1, 2, and 4 chlorines, 1, 2, 3, 4. But my ratio in each molecule is a 1:2. So here are the answers to the rest of the page. And you can pause. We did this together in class. We did a few in class, and then I put the rest up here, and they worked them on their own and self-checked, and I walked around and answered questions and made sure everybody was on the right track. So this is the answers to the rest of that page. If you have questions about this, you can also come and see me and we can talk about it. But I'd like for you to try these and then come back and self-check. So pause the video, and then we're going to move on to how we tell if it's ionic or covalent. So I hope you paused the video. I'm going to come back over here. we put in these definitions about what is ionic. So ionic is it's a bond between a metal and a nonmetal. And what happens is the metal loses an electron to the nonmetal, at least one. It can lose more. So you think about what that means. If something loses an electron, the nonmetal is actually gaining the electron. So if something loses or gains electrons, we call those ions. We called those ions the other day. So you can see that word ion is in the name ionic bond because the metal is losing an electron to the nonmetal. So this is a bond between a metal and a nonmetal. The first element will always be the metal. The second element will be the nonmetal. It will always be in that order. A covalent is kind of the opposite of that. This is between two nonmetals, and they are going to share electrons. The word covalent, the prefix, means to share. Valent means valence electrons. So covalent, they are sharing valence electrons. And so an example here would be hydrogen and oxygen, H2O, water. Covalent bond because hydrogen is a nonmetal, oxygen is also a nonmetal. So that's the way you tell the difference. Now, when we come back over here to our list, you can see that they're all listed as ionic. And the reason that they're all listed as ionic is because the first element is always a metal in these. And it's not uncommon to have a lot of ionic bonds because if you remember when we coded our periodic table yesterday or the day before, most elements are metals. The majority of the elements on the periodic table are metals. So therefore, there's only 17 nonmetals. So most likely it's going to be an ionic bond because you're going to have a metal bonding with a nonmetal. If you need help or have any other questions or concerns, come see me about this. Come see me about these. We're going to do some more practice with this tomorrow as we're gearing up for our Unit 3 test.